So after multiplication we get here 0 0 0, then 0 0 1 into 2 2, and here 0 0 6 2 12. This is matrix AB. And what about A square B? A square B will be 0 0 1 minus 6 minus 11 minus 6 36 1 2 1 36, and B is 0 0 2. So we'll have 0 0 1 into 2 2, here 12 minus 12, actually 36 to just 72. This will be our A square B matrix. And now the matrix U becomes 0 0 2 0 2 minus 12 and 2 minus 12 72. And after checking its determinant, so let's check it out. U is equal to 2 0 minus 4. So result is minus 8, and which is not equal to 0. Therefore system is controllable. System is controllable. And for observability, we'll check the observability test matrix. So observability test matrix V is equal to CT, AT, CT, and AT square CT, right? So for this purpose, first of all, we'll find matrix CT. So CT is 1 0 0. AT is 0 1 0 0 0 1 minus 6 minus 11 minus 6, and ATCT will be 0, here 1 and 0. And AT square CT, so first of all calculate AT square. So AT square will be like our A square matrix is here. So AT square will be 0 0 1 minus 6 minus 11 minus 6 and 36 1 2 1 36, right? So AT square CT will be 0 0 1. Now matrix V, observability test matrix, we have 1 0 0 0 1 0 and 0 0 1. Obviously it is an identity matrix, and rank of V is 3, which is equal to n. Therefore the system is observable. The system is observable, right? Let's take another example. Let let's take another example. Another example is like we have given matrix A. Matrix A is -1, 1, 0, -2. Matrix B is like 1, 0, 1, 0, 1, 1, and matrix C is like 1, 1, 1, 2, 0, 1, right? And we have to find out the transfer function of the system. Transfer function of the system. So we discussed in the last lecture that the transfer function is equal to C phi s b, and for this purpose we have to find out phi s, which is equal to Si minus A inverse. So first of all we have to find out Si minus A inverse. So Si minus A matrix is here S plus 1, minus 1, 0, S plus 2, and Si minus A inverse will be S plus 2 divided by S plus 1, S plus 2, 1 divided by S plus 1, S plus 2, 0, S plus 1 divided by S plus 1, S plus 2, which is equal to 1 by S plus 1, 1 by S plus 1, S plus 2, 0, 1 by S plus 2. This is our phi s matrix. And C phi s b will be 1, 1, 1, 2, 0, 1. Phi s, let's take it as F1, F2, F3, F4, and B is 1, 0, 1, 0, 1, 1. So first multiply this and this. We'll have F1 plus 2 F3, here F2 plus 2 F4, here F1, here F2, here F1 plus F3, and here F2 plus F4 multiplied by 1, 0, 1, 0, 1, 1, right? Now here we will get F1 plus 2 F3, here F2 plus 2 F4, and here F1 plus F2 plus 2 F3 plus 2 F4, F1 plus F2 plus 2 F3 plus 2 F4, here F1, here F2, and F1 plus F2, here F1 plus F3, F2 plus F4, and F1 plus F2 plus F3 plus F4. This is our matrix, transfer matrix, right? This is our transfer matrix. And on solving this, we will get our matrix. Clear? Next is we have given a matrix like A. Matrix A is equal to -1 0 0 0 -2 0 0 0 -3. Matrix B like 1 1 0, and matrix C is like 1 0 2, right? And we have to test for controllability and observability. So first of all, calculate all the variables like a square, ab, a square b, at, ct, atct, at square ct. Calculate these values, and then we'll find controllability test matrix and observability test matrix. So a square will be -1 0 0 0 -2 0 0 0 -3 multiplied by -1 0 0 0 -2 0 0 0 -3, and after multiplying we'll get 1 0 0 0 4 0 0 0 9. This is a square, and at square will be, this a is equal to at because it's a diagonal matrix. So at square will be our a square. ab will be -1, then -2, then 0. a square b will be 1 4 0. ct matrix we have 1 0 2. So at ct will be -1 0 -6, and at square ct we have 1 0 18, right? And now controllability test matrix u is 1 1 0 -1 -2 0 and 1 4 0. Obviously its rank is not equal to 3. The system is uncontrollable. Matrix V CT 102, ATCT minus 10 minus 6, AT square CT 1018. Here also the second row is all 0, and therefore the system is unobservable, right? The system is uncontrollable as well as unobservable, right? Next is, we have given a block diagram like summing point. Here we have 1 by S. Here a feedback of -1. Here we have F1. Here x1 dot x1. Here we have again 1, and below this we have a summing point. Here another input F2, an integrator 1 by S, a feedback -2, and here a gain of 1. This one is x2 dot and this is x2, and add these two to get the final result y. And we have to investigate whether the system is observable or not. Whether the system is observable or not. So from diagram only we can see that the output y can explain the state x1 and x2. Means both states x1 and x2 can be find out, can be traced out from this output y, and therefore the system is observable. But if we want to calculate it mathematically, then we'll first make it state equation and output equation. So state equation becomes x1 dot is equal to minus x1 plus f1, x2 dot is equal to minus 2x2 plus f2, and y is equal to x1 plus x2, right? And the matrix will be x1 dot x2 dot, here we have -1 0 0 -2 x1 x2 plus f1 f2, right? And y is equal to 1 1 x1 x2. So we have matrix A and matrix C. We have to test for observability, so we need only these two matrices. CT will be here 1 1, AT will be here equal to A, because it's a diagonal matrix, -1 0 0 -2. So V is equal to 1 1, and ATCT will be -1 and -2, and obviously the determinant is not equal to 0. Therefore system is observable. The system is observable, right? Another question from transfer function. We have given a matrix A. Matrix A is equal to 0, 1, 0, 0, 0, 1, 0, minus 2, minus 3, matrix B 0, 0, 1, and matrix C 1, 2, 0. So transfer function, we have C phi s B. What will be our phi s? What will be our phi s? So for phi s, we have to calculate Si minus A matrix, and Si minus A is S minus 1, 0, 0, 0, minus 1, here S, and 0 to S plus 3, and its inverse, we find its inverse Si minus A inverse, we'll get it like S square plus 3S plus 2, S plus 3, here 1, 0, S square plus 3S, here S, and 0, minus 2S, S square, multiplied by 1 divided by S cube plus 3S square plus 2S. And this is our phi s. This is our phi s, right? So C phi s B 1, 2, 0. Let's take it as F1, F2, 1, 0, F3, S, 0, minus 2S, S square. And here we have 0, 0, 1. So first of all, multiply this matrix. We'll find it as 1, 2, 0. Here we'll have 0, 0, and 1. Here 0, 0, S, and here 0, 0, S square, and it's not S, it's like F4, F5, F6, and F7. So here we find F4, F5, F7, right? I am writing it again, F4, F5, F7, and after multiplying with this, we'll get F4 plus 2F5, F4 plus 2F5, and what is F4? F4 here 1, and here S. So 1 plus 2S, 1 plus 2S divided by S cube plus 3S square plus 2S. This is our transfer function, right? This is our transfer function. So this is it for transfer function and controllability and observability. In next class, we'll do some more topics like diagonalization and similarity transformation, right? Thank you.